Hello, my little triglets. How is everyone today? All right, today is a big day. We're starting a new chapter, chapter 6. Chapter 6 has to do with, well, section 6.1 has to do with verifying trig identities. Now we have some basic identities. They are on page 642 that we can consider our trig Bible. Come on. What's going on here? All right, there we go. Trig Bible. Okay, you already know all of these, but they're all in one place. They're all on page 642. So if you're doing these problems, you might want to have your book open to that page. All right, verifying identities. It's like solving a puzzle. There are lots and lots of ways to solve puzzles, just like there's going to be lots and lots of ways to verify these trig identities. You need a little creativity and you need a little gumption to get these problems right. Some of them can be quite triggy, so you got to really try, and try again. All right, so the first process we're going to use is we're going to change all parts to sine and cosine. Okay, this is one process, so let's do a real simple one here. Secant of x times the cotangent of x equals cosecant of x. All right, so what we do is we put a line down the equal sign, and we start working on the left side. So secant, if I turn it into sine or cosine, is 1 over cosine. Cotangent is cosine over sine. And in algebra, you're allowed to cross these off, and you're left with 1 over sine. And we all know and love that as cosecant. And that's what we were trying to prove. So we proved this identity. So technically, they're verifying, but verifying is a fancy way to say prove. Okay, so these are trig proofs. This is some of my favorite stuff in trig, so I hope you enjoy it as much as I do. All right, let's try. Actually, before we try another one, I want to write down some things. On the last one, I said, like in algebra, you can cancel those out. But there are some things you may not do that you do in algebra. Okay, you may not add, subtract, multiply, divide, square, or square root on both sides. Okay, that's why we worked on the left side only. If you do any of these things, that means you're assuming that the problem is true to begin with, and we are trying to prove that it's true. So you can't put the cart before the horse. You can't say it's true by doing the adding and subtracting to both sides before we prove it's true. Okay, so those are big no-nos. Do not do that stuff. All right, let's try another one. This one's a little tougher. Sine of x, tangent of x, plus cosine of x equals the secant of x. So all this stuff on the left is supposed to be equal to secant. So let's turn everything into sines and cosines again. So I have sine x. Now what I'm going to do is make them all fractions, so I make sure I line up my fractions correctly. So tangent is sine x over cosine x, and then I have just a plain cosine x over here. So on the left, I have sine squared x over cosine plus. Now, I want to be able to add these two things together. Technically, they're both fractions if I think of this as over 1. So, what I'm going to do is put that over 1 and then get a common denominator. Looks like my common denominator is cosine, so I need to make this cosine and this cosine. Technically, this right here is 1, so I'm not multiplying both sides, and I'm only multiplying the left side by 1, which doesn't change anything. So that's a legal move. All right, so from there, I still have sine squared. Here I get cosine squared, and then they both have cosine x for the denominator, so I put that together. Now keep in mind what we're trying to do. We're trying to get secant. We know that is 1 over cosine, so I have the cosine. What is this? Sine squared plus cosine squared equals, and if you don't remember, you can look on page 642. But sine squared plus cosine squared is a very popular identity, and it's 1. And then 1 over cosine is equal to secant, and that is what we were trying to find in the first place. So voila, we're done. All right, that's turning everything into sines and cosines. Let's try another version here. The second way is we're going to use factoring. Factoring is where you bring stuff out front that they have in common, or you factor it like a quadratic into 2 parentheses. So let's try this one. Cosine of x minus cosine of x sine squared of x equals cosine cubed x. Okay, so working on the left side, what do they have in common? Looks like they each have a cosine, so I'm going to take that out front. And what's left is 1, because cosine times 1 gave me this cosine, minus sine squared. Okay, because if I distribute to there, I will get that. All right, notice over here I only have one thing. So I've got a parentheses here I need to change. And the other problem we just had was sine squared plus cosine squared equals 1. Well, I have 1 minus sine squared right here. 1 minus sine squared. If I bring this sine squared over here by subtracting, guess what I get? 1 minus sine squared equal to this. So I'm allowed to put cosine squared substituted in for 1 minus sine squared. And lo and behold, this cosine x times this cosine squared is cosine to the third. And that's what we were trying to find. And we found it. Okay, I got 2 more to show you. This one, maybe you use, this is a third way, use a combination of techniques. Let's try. I want to show you, if I had this, a plus b over c, is that legal if I break this fraction and this fraction apart? Is that legal to say it's a over c plus b over c? You see how that works? I like to call this process heart surgery because it looks like a heart and we're breaking it apart. We're cutting it apart. Now it can only be a right side up heart. You can't do it when it's upside down. Okay. So we're going to use that process in our next problem. So let's try our next problem. So I have 1 plus sine over cosine is supposed to be equal to secant plus tangent. Okay. So I'm going to do my little heart surgery here. Take that and that. So 1 over cosine plus sine over cosine. And we're almost done here. 1 over cosine is secant, and sine over cosine is tangent. And that's what we were trying to find. All right, put the line in there. Now this also works backwards. You know, if you got stuck and you weren't sure to start, you can work on this side and turn those in to 1 over cosine and sine over cosine and kind of work your way backwards to get to there. So if you get stuck on the left, go ahead and go over on the right side and try that. And you would do the reverse of heart surgery. All right, I got one more. Better buckle your chin straps because this one's a doozy. Okay, this process, I think we're on the 4th one, is combining fractions. Okay, combining fractions, remember, you need a common denominator. So if I have 1/3 plus 2/4, I want my common denominator to be 12. So I need this 4 by 4 and this one 3 over 3. And you'll get one denominator of 12. So you would say 4 plus 6 over 12. All right, so we're going to use that same idea here. All right, watch carefully. So we have cosine over 1 plus sine. Let me make that sine of x plus 1 plus sine x over cosine equal to 2 secant. Okay, we're going to work on the left side. Now, I have two fractions here, so I want to multiply them together. The common denominator, just like up here, is these two denominators. They're going to be our common denominator. This acts like the 3, this acts like the 4. So we're going to multiply each side by the other one's denominator. So this is cosine over cosine. This is 1 plus sine and 1 plus sine. Notice we're multiplying by forms of 1. Each of these, cosine over cosine is really 1, so we're not changing the integrity of the problem. All right, so let's multiply. We get cosine squared. Here, I am going to ask you not to distribute, because once you distribute, you make it addition, which you can't cancel. If I leave it multiplication between these two, I might be able to cancel something out. And because I only have 2 secant over here, it doesn't look like my denominator is going to want that 1 plus sine x in there. All right, let's go to the other side. This I need to FOIL. So I get 1 times 1 is 1. 1 times sine x is sine x. Another sine x times 1 is sine x. And then sine x times sine x is sine squared x. And on the bottom, we still have cosine 1 plus sine x. Okay, now we have a common denominator of cosine and 1 plus sine x. The numerator is everything on the top here, all of this. So let's look at it and see what we have. I have this and this together. If I add those together, isn't that sine squared plus cosine squared equals 1? So I have a 1 plus this 1 gives me a 2. All right, and then these two give me 2 sine x. All right, the reason I like that is they both have a 2 in it. Okay, they both have a 2, then we can factor the 2 out, so I get 1 plus sine x when I take both of the 2's from each part, and on the bottom I still have cosine 1 plus sine x. Now, can you see why I didn't want you to distribute? Because right now, this is multiplication. I can cancel that with that, and I'm left with 2 over cosine. But what we're really trying to find, let me get to the top here, is 2 secant. Well, isn't 2 over cosine equal to 2 secant? Because cosine on the bottom is the same as secant on the top. They're reciprocals of each other. So we just showed that it equals that. All right, so that's a doozy. You just got to kind of get used to the process. You have to practice these, practice these, practice these until you start getting comfortable with them and recognizing what you need to do. All right, we have a few more notes to take in class tomorrow. In the meantime, Trig is proving its love for you, so make sure you love it back. Ta-ta for now.